Okay, so let's talk about limits. This is something new. Um, the book talks about this, but the book goes into probably a lot more detail than I really want to go into for this. So I'm not really going to tell you to read the book. I mean, well, you can read the book if you want, but it's going to be more material than what I plan to do on limits. So here's what I plan to do on limits. Um, First of all, this is the definition. This should be pretty much the definition that you saw in Calc 1. But of course, not everybody remembers that because in Calc 1, we typically we do a pretty intuitive interpretation of limits and we don't look at the formal definition too much. But so suppose we have a function, say from the real numbers to the real numbers, or actually maybe it could be from, like, if D is a subset of real numbers, that maybe the domain is just D, maybe the domain doesn't have to be all real numbers. Um, so we have a function like f from some set of real numbers to the real numbers. We say that the limit as x goes to a of f of x equals L if for all epsilon greater than 0, and this means real numbers epsilon, so for all real numbers epsilon greater than 0, there exists a real number delta greater than 0, such that we have the following. Whenever x is a number satisfying this, so absolute value of x minus a is in between 0 and delta, and keep in mind that x should also be in D, the domain of f. That way we can talk about f of x. But as long as you have such a number x, absolute value of f of x minus L is less than epsilon. So this is a pretty technical definition. Many people find it very hard to fully understand it, but essentially what this is saying is that epsilon and delta are like measures of closeness. These are intended to represent small numbers, and roughly speaking, epsilon and delta are measuring like how close one number is to another number. So what this is saying is that no matter how close we want f of x to be to L, because epsilon is how close f of x will be to L. F of x minus L in absolute values is less than epsilon. So epsilon is like the closeness of f of x to L. So no matter what I want that closeness to be, there exists some delta telling me how close x needs to be to a in order for that to happen. In other words, I'm able to guarantee that if x is close enough to a, that f of x is close enough to L. Roughly speaking, that's what I'm doing, and that's why this definition makes sense. So let's use that technical definition to prove something pretty simple. Probably a Calc 1 student would do this in one step, except we wouldn't consider this a proof at the level we're at right now. So we're going to prove it using the above definition. And it will help if I do some scratch work first. What I want a is 1, so I would like this to imply this. So I'm going to put in what f of x is. I'm going to put in what L is. And let me simplify it, actually. So that's 2x minus 2. and I want that to be smaller than epsilon, right? In other words, what I want is, once again, this implies, and actually, I can pull a 2 out of this. In fact, maybe I should have divided by 2 instead and gotten this. And this tells me a lot. I would like this to imply this. So if absolute value of x minus 1 is less than delta, then I want it to be less than epsilon over 2. I mean, why don't I just make delta and epsilon over 2 the same? Now, having done this scratch work, let me attempt a proof. So what do I have to prove? I have to show that for all epsilon greater than 0, there exists a delta greater than 0 such that blah. So for my proof, since I have to show this for all epsilon greater than 0, I'm going to let epsilon be anything greater than 0. I just have to show that for all epsilon there exists a delta. I have a pretty good idea, based on my scratch work, of what I want delta to be. So here's the delta that I'm going to use, and this certainly exists. Now observe that, and what am I supposed to observe? I'm supposed to observe that if this is true, then that's true. And we basically already showed the work. I'm kind of just rewriting it, actually. So if this, so 0 less than x minus 1 less than delta, which is epsilon over 2, right? That's delta. And delta is, delta is epsilon over 2. Then two x plus 1 minus 3 equals, I'm just doing the same algebra that I already did. It equals this. I can pull the 2 out. And I know that this number is less than epsilon over 2, so that would be less than 2 times epsilon over 2. And hey, the 2's cancel, so I get epsilon. In other words, I just showed that f of x minus L is less than epsilon, which is what I needed to show. That's it. That's the proof of that limit.